Hello all, welcome back to the next video of acid, bases and salts. In the previous video, we had understood that salts can be acidic and basic depending on the acid and base taken. We also discussed various families of salts. Today, let's move on to learn more about some other salts. The first salt that we are going to discuss today is bleaching powder. We all are familiar with the process of bleaching where the colors from the cloth is removed to make it white. Bleaching powder has been used for this purpose since long. Chemically, bleaching powder is calcium oxychloride. Bleaching powder is also called chlorine of lime and it is a yellowish white powder. The raw materials required for the manufacture of bleaching powder are chlorine gas and dry slaked lime. Bleaching powder is prepared when chlorine gas is passed through dry slaked lime. The equation for this reaction is CaOH twice plus Cl2 gives CaOCl2 plus H2O. When exposed to air, it gradually loses its chlorine. Let us check the uses of bleaching powder. The widespread use of bleaching powder is in bleaching cotton and linen and washed clothes in laundry and textile industry. It's a very good sterilizing or disinfecting agent and hence is used in disinfecting drinking water. It's a raw material in the manufacture of chloroform, as well as it acts as an oxidizing agent in chemical industries. You might have seen your mother adding baking soda when she bakes a cake. Baking soda is a commonly used salt in our daily life. The chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. Its chemical formula is NaHCO3. Baking soda is also prepared from brine. So when we say baking soda is prepared from brine, let us understand the components required to prepare baking soda. Since the formula is NaHCO3 and we know that it's prepared from brine, one of the reactant is sodium chloride. Now, there is a carbonate element present in the baking soda. Hence, carbon dioxide will be required to prepare baking soda. The other two ingredients are water and ammonia. So, the chemical equation for this process is NaCl plus NH3 plus CO2 plus H2O gives NH4Cl plus NaHCO3. Baking soda is a mild basic salt. It is sparingly soluble in water and crystallizes out as white crystal. Let's check the various uses of baking soda. In the preparation of baking powder, baking soda, when mixed with mild edible tartaric acid, forms baking powder. This mixture is normally added to dough, which is used to make cake or bread. When the dough is heated, carbon dioxide is released due to the decomposition of baking soda. This carbon dioxide slowly bubbles out, making the bread or the cake to rise. This makes them soft and spongy. The chemical equation for this reaction is 2NaHCO3 gives Na2CO3 plus H2O plus CO2. The sodium carbonate formed here in this reaction gives the cake a mild bitter taste. That is why instead of using baking soda alone, baking powder is used. The tartaric acid present in it neutralizes the sodium carbonate and gives a sweet taste to the cake and pastries. Hence, if you want to make fluffy and soft cakes and pastries, you need to use baking powder. Soda acid type fire extinguishers contain sodium bicarbonate and sulfuric acid in separate glass ampules. When the knob of the fire extinguisher is struck against a hard surface, the ampule is broken and sulfuric acid mixes with sodium bicarbonate producing carbon dioxide. We know that carbon dioxide is a very good extinguisher of fire. Being a mild and corrosive base, baking soda is also used as an antacid. It neutralizes the presence of excessive acid and hence gives a relief from the pain and irritation that is caused during indigestion and acidity. The next salt that we are going to discuss today is washing soda. Chemically, washing soda is sodium carbonate decahydrate. It is a hydrated salt and in its anhydrous form, it is known as soda ash. What is the meaning of a hydrated salt? That we will learn in the next video. Washing soda is a white crystalline solid. Let's understand how washing soda is prepared. When baking soda is heated, it gives out sodium carbonate. The chemical equation for this reaction is 2 2NaHCO3 gives Na2CO3 plus H2O plus CO2. Now, the next step is recrystallize the sodium carbonate formed in the above reaction. So Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. Let's understand the uses of washing soda. As the name suggests, it is used for washing of clothes. It is a constituent of soap powders. So washing soda is a cleansing agent in domestic purposes and in laundry. It's also a raw ingredient or a raw material in the preparation of glass, soap and paper. Washing soda helps in removing permanent hardness of water. You must have seen beautiful designs on the ceiling and walls of room in many houses, as well as whenever you break your hand or leg while playing, the doctor gives you a plaster of Paris bandage. Yes, plaster of Paris is also a very familiar salt to you. Let us understand more about plaster of Paris. Chemically, plaster of Paris is known as calcium sulfate hemihydrate. It is obtained by heating gypsum. Gypsum is calcium sulfate. When gypsum is heated at 373 Kelvin, it loses 1.5 water molecules and forms plaster of Paris or calcium sulfate hemihydrate. The temperature in this reaction should be controlled, or else gypsum may change to anhydrite or dead burnt plaster, which does not have any properties of POP. The actual formula of plaster of Paris is 2CaSO4.H2O. That means 2 molecules of calcium sulfate is sharing 1 molecule of water. It is a white powder, and when mixed with water, it quickly sets to a hard porous mass. This is why POP is widely used in making statues, molds in toys, to cover walls and roof, plastering fractured bones, and in making molds of teeth to be replaced in dentistry. It is also a preferred building material for fireproofing purposes. POP should be stored in moisture-proof container. This is because the presence of moisture will cause slow setting of POP, turning it into gypsum. This will make plaster of Paris useless after some time. So when plaster of Paris is mixed with water, the equation is CaSO4.12H2O plus 3/2H2O gives CaSO4.2H2O. And hence POP should be immediately used once it is mixed with water. Hope you are now well clear with the preparation, uses and chemical names and formulas of various salts that we have discussed in this video. Thank you for watching the video. Show your support through your likes, shares and comments. Subscribe the channel for more contents of class 8, 9, 10 science.